Welcome back. In this hands-on demo, I'll guide you through creating a private subnet and configuring a NAT gateway to allow secure outbound internet access. In the last lesson, we covered network address translation, NAT, NAT instances, and NAT gateways. And we learned that NAT gateways are the best option for enabling outbound internet access for private subnets while keeping them isolated from inbound traffic. Now, let's put that knowledge into practice and configure a private subnet with a NAT gateway step by step. Let's get started. Step 1, creating a private subnet. First, we need to create a private subnet within our VPC. Navigate to the AWS Management Console and open the VPC dashboard. Select Create Subnet. Now, let's fill in the necessary details. VPC selection. Choose the VPC we created earlier. Subnet name. I'll name this My Private Subnet to make it easy to identify. Availability zone. I'll select US East 2B, but you can choose any availability zone within your region. 24 IPv4 CIDR block. Enter 10.0.2.0/24, which provides a range of 256 IP addresses for this private subnet. Click Create Subnet, and AWS will provision the private subnet. Reminder, by default, a newly created subnet in AWS is private. It has no direct internet access unless explicitly configured. Now that we have our private subnet, let's move on to setting up a NAT gateway so that instances in this subnet can access the internet outbound, but still remain inaccessible from outside users. Step 2, creating a NAT gateway. A NAT gateway allows instances in a private subnet to connect out to the internet for updates, patches, or external API calls, while preventing anyone from initiating connections into the private subnet. To create a NAT gateway, in the VPC dashboard, navigate to NAT gateways in the left menu. Click Create NAT Gateway. Now let's configure the NAT gateway. Name, I'll call this My NAT Gateway. Subnet selection. A NAT gateway must be placed in a public subnet since it needs internet access. Select the public subnet we created earlier. Elastic IP allocation. Click Allocate Elastic IP to assign a static public IP address to the NAT gateway. Why do we need an elastic IP? An elastic IP, or EIP, is a static public IP address that remains assigned to your NAT gateway even if it restarts. Without an elastic IP, the NAT gateway would lose its public IP, disrupting outbound connectivity for private resources. Once everything is set, click Create NAT Gateway. AWS will take a few moments to provision the NAT gateway. While we wait, let's configure the route table so that traffic from the private subnet knows how to reach the internet through the NAT gateway. Step 3, configuring the route table for the private subnet. By default, subnets use the main route table of the VPC, but we need to create a custom route table for the private subnet to route traffic through the NAT gateway. Navigate to Route Tables in the VPC dashboard. Click Create Route Table. Name it. I will call this My Private Route Table. Select the same VPC we've been working with. Click Create. Now let's update the route table so that all internet-bound traffic from the private subnet is sent to the NAT gateway. Select the route table you just created. Go to the Routes tab and click Edit Routes. Click Add Route, then enter destination 0.0.0.0/0. This represents all traffic destined for the internet. Target. Select the NAT gateway we created earlier. Click Save Changes. Step 4, associating the private subnet with the route table. Now that the route table is configured, we need to associate our private subnet with it so that traffic from this subnet follows the correct routing rules. In the route table section, click on Subnet Associations. Click Edit Subnet Associations and select My Private Subnet. Click Save. At this point, the private subnet is properly configured to route outbound traffic through the NAT gateway while blocking inbound traffic from the internet. Step 5. Testing the configuration with an EC2 instance. To verify that the NAT gateway is working, let's launch an EC2 instance in the private subnet and check its network connectivity. Navigate to the EC2 dashboard and click Launch Instance. Select Amazon Linux or Ubuntu as the AMI. I will be using Ubuntu. Choose an instance type, e.g. T2 Micro. Under Network Settings, select the VPC we created earlier. Choose My Private Subnet as the subnet. Disable Public IP Assignment since it's a private subnet. Select or create security group. I will be using an existing one which has ports for HTTP, HTTPS, and SSH open. Proceed with the rest of the default settings and launch the instance. Once the instance is running, let's connect to it using EC2 Instance Connect. Open the EC2 console, select the instance, and click Connect. Choose EC2 Instance Connect. Connection type, EC2 Instance Connect Endpoint, which we will be creating. Navigate to EC2 Instance Connect Endpoint. Click on Create Endpoint. Step 6. Create EC2 endpoint in a private subnet. We'll be directed to Create Endpoint in VPC. Enter a name of your choice. I will be using my private EC2 endpoint. Type EC2 Instance Connect Endpoint. Select the VPC where your private subnet is, My VPC. Select Security Group. I will continue with Launch Wizard 4, which opens HTTP, HTTPS, and SSH. Subnet. Select your private subnet and click Create Endpoint. It will take some time for the endpoint that we just created to be available. Make sure you are patient. Now that our endpoint is available, let's go back to EC2 Instance Connect. Select the endpoint you just created. You can refresh the list if it doesn't come up immediately. Click Connect. Now let's test internet connectivity. First, check if the instance can reach the internet by pinging an external site using the ping command. This test will be a success, meaning our NAT gateway allows internet connection into our instance. Now let's delete our NAT gateway. Let's try pinging the external site again. This test would fail because there is no longer internet access in our EC2 instances. This confirms that our NAT gateway is working correctly, allowing resources to reach the internet while keeping them invisible. Recap and what's next. In this demo, we successfully created a private subnet within our VPC, provisioned a NAT gateway in a public subnet, configured the route table to direct outbound traffic through the NAT gateway, ensured private subnet instances can access the internet securely without being exposed. This is a fundamental networking setup in AWS, especially for secure architectures that require controlled internet access. In the next lesson, we'll explore security groups and network access control lists. Thanks for following along, and I'll see you in the next video.